Okay, and this is our last section in linear relations, chapter 1. We're looking at perpendicular and parallel lines. Okay, so I'm sure there's already a good amount of knowledge of these concepts, but let's go through it and also relate to gradients. Going to be the real take-home message from this YouTube. Okay, so parallel lines. Firstly, they look a bit like this, don't they? They never meet. They're the train tracks. Two lines that if you want to define it, which we do here, they have the same gradient, and we denote, symbolize that they're parallel. Lines are parallel with these little arrows. So we worry less in senior maths about what sight and scale, what things look like. For instance, I could do this and put two lines there, and suddenly those sides are now equal, and I've got to proceed through this problem as if that's the case, and this is an isosceles triangle, even though on sight that looks ridiculous. Now obviously that was a bit misleading, but my point is that we go now on symbols. So we're not too worried about getting perfectly. It's very difficult to draw two lines that have got exactly the same gradient and will never meet. But by putting some arrows on those lines, that says these are parallel, and so that's the property that we will assume as we proceed through this problem. Okay, so that's what parallel lines look like. And perpendicular lines, while we're at it, we know that lines are perpendicular when we see this little box in here to denote that they're at right angles. So these are perpendicular lines, these are parallel lines. Now parallel lines have exactly the same gradient. Right, so these have parallel lines. Parallel lines have equal gradient. Okay, exactly the same. So that's how we identify parallel lines. And perpendicular lines have perpendicular lines have gradients that what is going on here? That are the negative reciprocal of each other. All right, that's a little bit more complex, isn't it? Parallel lines, they're equal. Perpendicular lines, these gradients are the negative reciprocal of each other. That's going to take just a little bit more explaining. So let's do that. If we have a look at, I'll show you. Let's do an example here. So we've got a line. Let's say, let's just draw a random old line in here. Let's say the gradient of this line is 2. So we'll say m equals 2. And we want to have a look at the perpendicular line to it. So there's the line that makes a right angle with it. And we want to, okay, if that's got a gradient of 2, then what's this gradient? So if this one goes, and I'm just going to apply or call on a bit of logic here. If this one goes across 1 and up 2, which is what a gradient of 2 means, doesn't it? Well, across 1 and up 2, across 1 up 2. Then what's this one going to do in order for it to be perpendicular? Well, it's going to do the opposite. It's going to go along 2 and up 1. It's going to go along 2 and up 1. So what do you think the gradient's going to be? It's going to be rise over run's a half. But the other thing about it is that it slopes the other way. It has to slope the other way. If I've got two lines that are perpendicular, they've got to slope the opposite ways, in that this red line is a positive gradient, but the blue line's a negative gradient. So we put a minus out the front there. So you can see 2 and minus a half, they're reciprocals of each other, 2 over 1. Remember, the reciprocal means the numerator and denominator are exchanged. They exchange positions. They swap positions. So 2 over 1 becomes 1 over 2, but not just reciprocal, negative reciprocal. So 2 over 1 becomes minus 1 over 2. So if I've got a line, let's go for another line here, let's flatten it out at minus 1/3. What's the gradient of the perpendicular line going to be? See, the flatter that is, then the steeper this one's going to be. And if this is going 3 along and 1 up, this is going 1 up. Sorry, if this is going 3 along the run and 1 up, this one will go 1 on the run and 3 up. So our gradient will be the reciprocal of this and also the opposite sign. So this is a negative, this one's going to be positive. So 3 over 1, which we'd write as 3. So that's perpendicular lines. Negative reciprocals, parallel lines, same gradient, dead equal. Okay, let's look at how this appears in questions and look at some examples now. So the first one here is, are the following pairs of lines parallel, perpendicular, or neither? So we look at these two lines here, y equals a half x plus 2 and 2y minus x equals 5. They're both linear equations, they both result in lines. So they've got gradients that we can consider, and that's what we need to do in deciding whether they're parallel or perpendicular, or in fact neither. So what's the gradient of this line? That's all we want. We just want to know what the gradient is. Well, that's easy because it's in gradient intercept form, isn't it? There's my gradient right there. So my gradient's a half here. This one's not so obvious. I've got to make y the subject. So let's go about doing that. 2y equals, the minus x comes over the right-hand side, becomes plus x. X plus 5. Now I'm going to divide by 2, aren't I? Because I've got 2y. And in doing so, I take each term and divide by 2. In this case, just a half x. Divide x by 2 and 5 over 2. So my gradient is a half. So these two lines have the same gradient, so therefore they're parallel. Okay, we'll have a look at another pair of lines. Y equals minus 3x minus 8, and y equals 1/3 x plus 1. So let's pull out the gradients from these. My gradient here is minus 3, and my gradient here is 1/3. Are they the negative reciprocals? Well, they're not the same, so we can rule out parallel. Are they the negative reciprocals? Yes, minus 3 over 1 and 1 over 3. Yes, they are. So they are perpendicular. Okay, one more example. Okay, here's our example. Find the equation of the line that is parallel to y equals minus 2x minus 7. Parallel is an important word, and parallel to this line. So what we can gather from that, what's the gradient of this line here? What's this minus 2, isn't it? So the gradient of this line is minus 2, and the line that we want the equation of is parallel to it. So our equation, our line, let's call it our line, has m equal to minus 2 because it's parallel to this, and it also goes through 1, 9. So what we're going to do here is use the formula that we came up with in the last lesson, and that is y minus y1 equals m x minus x1. Actually, it's 2 lessons ago, where this is my x1, y1 right here, and here's my gradient. So substituting those values in, y minus 9 equals m is minus 2, x minus 1. I just have to run this through now, minus 2x plus 2, and I'll take the 9 across, so I'll finish with y equals minus 2x. You can see it's got the same gradient as this guy. The 9 becomes plus 9 over here, so it's minus 2x plus 11. There's the equation of the line that's parallel to this and that passes through 1, 9. Okay, let's take on the last exercise in chapter 1 now, exercise 1H. We'll do that on Monday. I'll see you then.